Hey everybody, this video is about uniform circular motion. So let's say you are going in a straight line this fast, and then later you're going this fast, right? So now you're accelerating, right? And the acceleration is toward the right. What if you're going 3 meters per second to the right, and then later, a few seconds later, you're going this fast? Right, so now your acceleration is to the left, or you're slowing down. What about you're going 3 meters per second to the right, later, you're still going 3 meters per second. So now the acceleration is 0. How about now? So you're going 3 meters per second. Later, you're still going 3 meters per second, but in a different direction. So your acceleration is not 0, right? Because the magnitude of the velocity, the speed, is constant, but you change direction. And velocity is a vector. Vectors have both magnitude and direction. So in this case, the magnitude stayed the same, but the direction changed. So that's the topic today. We're exploring kind of a particular case. What if you're just going in a circle at a constant speed? So that's uniform circular motion. Uniform meaning constant speed, and then in a circle. Okay. So let's say, right, like you're going counterclockwise. So, right, as you go, the velocity is always tangent to the path, right? Tangent. What about the acceleration? So the acceleration turns out to be this way. Acceleration. This way. And actually, the acceleration vectors all point toward the center of the circle. And then that word is centripetal. So centripetal is an adjective that means toward the center. Okay, so this is centripetal acceleration. Centripetal acceleration. And I'll just tell you the answer is the magnitude of the centripetal acceleration is this for the speed v, and for the radius of that circle r. So this is the magnitude, v squared over r, and the direction toward the center. Okay, so that was like the quickest lesson ever. One more thing about circles. If you're going in a circle, think about just average speed. How it's just like distance over time. So let's just call this average speed v. And distance, if you're going in a circle, then that's the circumference, right? So 2 pi r, the circumference. And the time, I'll just call time t. So for radius r and period t, period of time, right? The period of time it takes to go around the circle. Right, so this is specifically for a circle. So let's just jump straight into an example. Let's say you're tracking a vortex in the ocean, like in the Great Pacific Garbage Patch. There's like microplastics going around in a big vortex, and you deploy a sensor to measure this, and the sensor includes an accelerometer. So say you measure the centripetal acceleration, and then use satellite tracking to determine the radius of the vortex. So let's say you know both the acceleration and the radius. Can you tell me the speed and the period? So let's just say, let's do one thing at a time. Speed. Okay, so all the formulas in the world that you know, right? You know this one, and if it's going in a circle, you know this one. And you just think about what is known and what is unknown. So I know the acceleration, I know the radius, the only unknown is speed. So there you go, you just solve that, right? Solve. Done. Right? Let's say, next problem. Find the period. Like, how long does it take for your sensor to go around the circle? So all the formulas in the world that you know, right? You know this one, and you know this one, and now you're given the acceleration and the radius, but we don't know v, we don't know t. So actually, there are two unknowns, but then we have two equations. Right, so then you can solve these whichever way. Like you could solve this for v, put it here, which is what I would do. But just to show that you don't have to, you could solve this for v and put it there. Let's just try that. So v, so 1 over r times v squared. And v squared is this thing squared, right? So then that's 4 pi squared r squared over, okay, one of these cancels one this. Okay, so then we have, let me just rewrite it. Okay, now let's solve for t. So just put this on that side. And then square root. There you go. There you go. Okay, so, and then my focus is really the method, right? Not like you memorize these formulas. It's, the point is the method of, right, figure out all the equations in the world. I know these, right? And then it was a matter of figuring out what's unknown. These are unknowns. And then you do the math to solve. Okay, let me know if you have questions. I'll see you on the next video.